Hi there, this is section 5.1 and now I wanted to go over question 49 and bonus question number 55, I think it is. 55 on page 214. So the probability is getting a little bit more challenging. So the question asks, consider the experiment of tossing two dice and observing the sum of the dice. So in the previous problems we were just tossing or rolling, I like to say rolling instead of tossing, but rolling one die, and now we're doing two dice. So the question 49 says, what is the probability that the sum of the two faces on the two die will be 5? They tell you to use figure 5.3 on page 207, so you're welcome to do that. If you don't have that, or if you're having trouble on a test because you don't have the figure with you, you can do it this way. Okay, this is how I did it. I made a little chart. So you have one dark green die and one light green die. I would have gone green and red, but they did dark green and light green. So here's the total choices for the dark green, 1 through 6. Here's light green, 1 through 6. And inside I'll have the sum. So inside here, so 1 and 1 and 2 is 2. So 1, 1 and 2 is 3. This is the sum of the total. And I'm doing this because the question asked for the sum, looking at the sum. So I got 2, 3, 4. Do you see a pattern here? 5, 6, 7. Okay, so now for 2 and 1, you can see the total is 3. Do you see what's going to happen here? You're seeing the pattern 4, 5, 6, 7, and 8. I'm going to pause it for a second while I fill in the rest of these so you don't have to watch me type. So I'm done typing in all of the sums. So these are all the numbers, all the outcomes for the sum of the two die. You can see that 2, getting a 2 and getting a 12 are the least likely because there's only one way you can get each of those numbers. So the question, if I scroll up to the top, says we want the probability that the sum equals 5. So these are all the sums. Here's a 5. So there's 1, make that red. 2, you can see they're in a nice diagonal, so it makes it easier. Some of you could see this right away and you don't have to make a table. So if you could just get it intuitively, or if you can see the answer right away, clearly you do not have to make this table. This is only in case you're having trouble visualizing all the outcomes. So in this case, these are all the ways you can get a 5 along this diagonal. So that's if you get a 4 and a 1, and then a 3 and a 2. So there's 1, 2, 3, 4 different ways you can get a 5, and there's 36, because it's 6 times 6, total outcomes. So the answer is 4 out of 36 is 1/9. So what's the probability that your sum equals 5? The answer equals 1/9. Okay, so question 55. Which probability or which event has the greatest probability? So what is the most likely sum? Again, some of you may see this intuitively. If you look at this total outcome of sums, which one happens the most often? So you can kind of look, 2 doesn't happen very often, 12 does not happen very often. Aha, 7. There's this whole diagonal row of 7. And that kind of makes sense because you could imagine you can get a 7 in lots of different ways. You can get a 7 with 6 and 1, 5 and 2, 4 and 3. So the most likely outcome is rolling a sum that equals 7, and the probability is 1, 2, 3, 4, 5, 6 out of 36. Probability of getting a 7, so getting sum equal to 7, and the probability of sum equal to 7 equals 6 divided by 36, which is 1/6. So that's lucky number 7. I think you get a lot of money in craps if you roll a 7. But you'll notice the probability is still not that great. But 1 out of 6, you roll 6 times, maybe you'll get lucky. Okay, so that's how you do question 49 and question 55.